Hi, my name is Natalie, and today I'm going to present and talk about infrastructure as a code and what are some similarities with the baking process. So let me iterate. I already mentioned my name. I am a software engineer. I work at many interesting companies where after a certain time now I end up in senior DevOps engineer role. I am also a mentor. I have 3 dogs and I love baking. That's why I'm going to start with a little bit of a history. What is infrastructure as a code? Because it's not a brand new concept, but it is still kind of newish. The adoption of it is newish in the industry these days, and a lot of companies are trying to switch to this approach. And the history for that is in the past, a lot of things were managed by hand. In the infrastructure world, by hand, I mean a lot of things were done manually. A lot of configurations were done manually. They were not stored anywhere for sharing, meaning team couldn't iterate on things at the same time. The way things were implemented, most of the time it was application, one server, which was not always efficient in terms of resources. And then the global economy and a lot of applications in the cloud move things to the kind of flow of the data centers, where companies are less trying to host everything by themselves and go into the cloud. And every resource, every app, they're trying to make it more globally usable and close to the user base, what company or product is trying to cover. And then in the future, we start using hypervisors, which is again newer, modern technology. Comparing to it, came up like a couple 10 years ago, maybe less. And now the era we are in, I call it more like a hybrid era, where we have old technology, we have new technology, where we're in some companies are in the state where they have to manage all of it. At the same time, try to move to the newer, but still managing legacy stuff. And I think this is the biggest problem right now. How do we actually manage the entire infrastructure? That's why I think this topic is pretty relevant to understand. And the reason I try to explain it from the baking concept is I am a mentor, and a couple years ago I was mentoring a person who was doing an internship at my company, and part of the internship project was actually finishing everything by doing infrastructure as a code. That was a company practice. And I found a lot of people being great engineers, trying to understand infrastructure field, have very little understanding what is infrastructure as a code. And then I started asking myself, how do I explain this concept? And basically my intern name was Laura, and kind of we talked a lot. And at some point, I knew that both of us love baking. And somehow one day I was like, what if I try to explain infrastructure as a code from the processes and the way it managed from the baking concept? And let me explain you my infrastructure as a code definition. So there is something from Wiki, which is infrastructure as a code is the concept of writing code to represent your infrastructure requirements, to use some kind of a tool to apply those changes to your cloud or on-prem environment. And my definition, it's kind of simplified, but it still makes a lot of sense, which is it's a concept of writing machine-readable files, let's say recipes, that generate service components like cakes or bread, and manage those cakes or something in the store, which could be sold at the large-scale infrastructure. And if we translate or try to translate it to baking, let's first distinguish what is baking. Baking is a method of preparing food by following a set of steps defined in the recipe. Simple, we kind of all familiar what it means, right? And recipe in this scenario is set of requirements or instructions that describes how to prepare or make something, specifically your dish of prepared food. And I feel like they can be closed, defined, this way, that baking is a concept of writing human readable set of instructions to generate the food. It makes sense, right? And infrastructure as a code is a concept of writing machine readable set of instruction to generate infrastructure resources. So in both ways, there is some file or a recipe which human or machine can read and understand. And by doing that, after that, apply something on top of it to receive food or some infrastructure resources. Probably I should mention infrastructure resources, and in this scenario, it could be anything. It could be networking, it could be some kind of a tool, it could be a server. So any infrastructure source is the product of infrastructure as a code. And in this slide, I'm trying to show that there are a lot of different tooling these days on the market. They have different functionality. They can help at different stages because infrastructure as a code can solve different problems. There is orchestrating, there is provisioning. So all these tools, they have different use cases. Sometimes they overlap. But market is full of different options, and I feel like company have choice these days in terms of adoption. Let me now explain what is application, and because this world is now built on microservices, at least every good technical company is trying to move to that concept. And application or a service or microservice in the cloud is not more like it's a code which consists, which is hosted on a cloud. It probably has some networking. It like if you're using some cloud account, it could be multi-cloud or different cloud accounts. It could be different databases, right? So application or service requires not just code to be written, but to put it in infrastructure environment, it needs a lot of other supporting tools or sets of tools or resources to function appropriately and actually to do the job it was meant to do. So there are also scenarios where we these days adopting, like for example, Kubernetes, like on this slide, you can have different environments, and environments can be differently used. Let's say for development, you can have testing environments. For development, you get development environments. If you, for example, trying to replicate the same application in different environment for testing, you can have testing account, and for production, it could be production account. So the problem here is not just to have an application, know the resources, but also an easy way to replicate the same system, the same setup on any environment or maybe any cloud. And if we talk about it, it's something like a Lego where you can have different pieces, and configuration management help you to put this Lego in something together. So to make it happen, if we talk about baking, let's see what kind of ingredients we can use. What kind of ingredients we can use for this application, right? To build infrastructure as a code. So first of all, we probably need to decide on environment. Is it some kind of a cloud environment? Could be on-prem or bare metal, as well as like what kind of language we're going to use, right? As on one of my slides, I pointed out in the beginning that it should be machine readable. So what kind of code or language we use to talk to machine or a tool to process it and to generate something that called infrastructure resource. Example here is something like HCL for Terraform tool, or let's say YAML for like tools like Ansible. And for infrastructure as a code comes together with automation, and it's really efficient if this automation can be run or implemented maybe with the CI/CD pipeline, which is continuous integration and continuous delivery pipelines. Maybe some generation of the configuration could be part of that, or maybe applying this configuration to the cloud or environment can be done with the help of those tools, which is one of, I would say, really important ingredient in this whole process. And one of very important part as well is source code management, because as I mentioned, the problem from the past was in this whole process was that the configuration wasn't represented anywhere. So let's say there was one person who made a change and the other team members would never knew what has changed until they would go log into the system, maybe check some logs or debug some processes to understand what was applied. So these days, with configuration as a code, with infrastructure as a code, there is a way to store all this configuration in your source code, which is GitHub or GitLab, depends on what companies are using. So it's very important ingredient in this whole process as well. So now let's go like into some major concepts which I was trying to represent in this presentation, to just give you an idea what are these concepts are, what are these processes are, and when you next time you hear what is infrastructure as a code, you will have an understanding, apart from some configuration, what is happening, what is the process of building it, maintaining it, and being part of the infrastructure process as an engineer. So there are two concepts I want to start with, which is configuration management and provisioning. These two categories are not mutually exclusive, and some tools I'm gonna present as examples can have both functionalities. So nothing is wrong with that. This is just part of the process. So configuration management. Configuration management is an automated method for maintaining computer system and software in a known consistent state, which is very important that no matter what happened, in the end, we will have a consistent state and we kind of know what is the state, right? And there are many benefits of understanding this concept, because configuration management will provide consistency of systems and software. And if we combine it with some automation, it will create a lot of efficiency in the processes. As I mentioned before, it will completely replace manual configuration, which is very tedious, like, for example, during the incident management. And if I try to translate that into like baking analogy, I can say when you're a big bakery and let's say you have a process of like delivering pies, then when you have a ready pie filling ordered from like say third party and ready crust, and you just making a pie in the end, this is kind of what this concept is about, because you know what pie crust you're getting and what kind of filling is there. And it's easy for you to produce something like a pie and just keep selling it consistently, right? Everyone knows that you need 2 ingredients. You can have for big production, you can have some kind of machine which just connects those two and makes it as a product. Tools which help to manage configuration can be Chef, Puppet, Red Hat, Ansible. There is also SaltStack, and these tools are designed to install and manage software on existing servers, or let's say if we going to translate this in the cloud, it could be EC2, which is also a server just in the cloud, and I'm talking about that. Provisioning. Provisioning is a bit different process. It's not the same as configuration, although I found that a lot of people are getting confused about this specific process. Provisioning is actual process of setting up an infrastructure. So there are certain steps that, for example, are required to manage access to the data or resources, and maybe make them available to users in the systems, and those steps known as provisioning. as I said, it's not the same as a configuration. What benefit having provisioning in your infrastructure process or deployment process? It's actually increased visibility in the environment to make it more stable, to make it more consistent. Those steps like benefit to manage access to the data and resources, as well as sometimes company going through some kind of compliances, and this process helps with achieving compliance requirements. And again, if we're talking about baking analogy, let's say if you're designing a recipe and you just selecting ingredients, or you're trying to build the steps how to make a perfect crust, a perfect pie, and you're actually not worried about assembling this, but you're just trying to define the steps how to get there, that's kind of what provisioning is. And there are a few tools available on the market. I personally think that Terraform is one of the better choices these days because it's really cloud agnostic. It has a lot of different providers that help you to reach to the state of your infrastructure, as well as it's really easy to adopt. And it creates like cloud agnostic approach to your infrastructure. There are two more concepts, which is mutable infrastructure versus immutable infrastructure. And it's really easy to explain by just saying that mutable infrastructure can be updated, configured as per your requirement, depend on what you're doing. Let's say if you are using Ansible and you're trying to install something like OpenSSL, it will run software update on your existing servers, and the changes will happen in place. Right? For baking analogy, if we talk about mutable infrastructure, we can say there is a Marinki recipe, right? You cannot change Marinki recipe just like adding something like adding no sugar, because in that case, the Marinki will just not going to be made, right? So mutable is something which is consistent. And in mutable infrastructure, it's something obviously opposite. It's something that cannot be modified in your infrastructure. So once it's created and deployed, it is immutable. And the way to like replace it or deploy it is by creating every time a new deployment of this particular infrastructure resource. So for example, if you used like previous OpenSSL example, you would create a new image of your server with OpenSSL already installed on the server. And then you deploy that image across of your fleet of the servers in your cloud or on-prem environment. And here what I'm saying that you can modify the banana bread recipe in your baking, but you will still build those banana breads and as one piece. And here's some visual example, more technical. Let's say in Ansible world, if I have EC2 is a server, if I'm trying to build an EC2 and I have 10 of those, and there, I put some image on my server, and this is the type of my server. And let's say I want to change from 10 to 5, right? How do I do it with mutable versus immutable infrastructure? In Ansible world, we will have to change the count as we go. And let's say in Terraform, we will just also change the count. But after applying that to our configuration, it will build 5 extra resources that we will request. It's a little bit, I have a note here that Ansible kind of doesn't allow you to use tags to kind of search for your machine. So this is just like a representation of the process, but it's not a real implementation. And 2 more concepts about approaching infrastructure as a code, which is declarative and imperative. Declarative approach focuses on what the eventual target configuration should be, which is sometimes called procedural, and imperative focuses on how the infrastructure is to be changed to meet this. And going back to my baking analogy is instructions in the recipe when you're trying to make something from scratch. Going back to example of banana bread, when you have all the ingredients and you like when you write the code that specifies step-by-step instruction how to achieve this like perfect banana bread. And in declarative world, it's more like you have everything kind of in desired state. Let's say if you like bought a frozen oatmeal cookie and you just put it into microwave for 1 minute, so you kind of already have a ready state, and you kind of use some tooling like microwave to apply to that state, and you got the perfect cookie in this scenario. So summary of this talk is that infrastructure is complicated. It's takes some time to learn everything in infrastructure, but some concepts are just easy to understand, and then you have that in mind. It helps you to move forward with lots of tooling available on the market. Sometimes researching those tools and understanding their purpose is confusing. It can get even more confusing the more you like trying to approach something with researching the tool without understanding the basic concepts. So by giving this talk, I was trying to give you an idea that sometimes just understanding the principle is better approach versus starting researching the tool. So if you know where you're trying to be, what you're trying to get, it's easier to just find, oh, this tool can do this, and I can just use this tool to make this process happen. And something I hope you learn, that infrastructure is very interesting, and it changes pretty often, specifically when companies are growing, then they're trying to maybe approach more modern technologies. And it's good if your process, if you're trying to reach automated infrastructure, I call it, where there is no human interaction, there is no manual changes, right? It's good when your infrastructure is represented in some kind of a way, which is configuration management, and it's basically accessible to the whole team, to the whole engineering team. They know what's going on. They know what changes are happening at the, let's say, with the current going commit, right? It also provides you a consistency. So you know what configuration is there, it's consistent. It cannot be tomorrow, you can apply something to this configuration, but the whole stable set of your resources will still be present and defined somewhere. And it's also help you, let's say if you're growing or you're trying to build different environments for some customer usages or even internal usages like dev and test team, it easily help you to replicate all these resources, build them in different environments, different clouds, using different tooling, which should not be focus of understanding and solving these interesting concepts. Thank you so much for your time, and I appreciate you coming on my talk. Have a good day, everyone.